Welcome to JD's Prep. In this problem, we are shown three functions, one given as a graph, one given as an equation, and one given as a table. Then we are given four statements about the y-intercepts for these functions. The first statement says that the y-intercept for h of x, the function given in the table, is greater than the y-intercept for f of x, which is the function given in the graph. The second statement says the y-intercept for f of x is greater than the y-intercept for g of x, which is the function given as the equation. The third statement says the y-intercept for h of x is greater than both y-intercepts for the other two functions. And the fourth statement says the y-intercept for g of x is the one that is greater than the other two. So since all of these statements are revolving around the y-intercepts and how they compare between the functions, we want to solve this problem by finding the y-intercept for each one of the three. Then we can compare the numbers that we get back for our y-intercepts to those statements to see which one is actually correct. If our function is given to us as a graph, as it is for f of x, what we're looking for is the y-coordinate of the point where the graph crosses the y-axis. That point is located right here, and the y-coordinate of that point is 1. So f of x has a y-intercept of 0, 1. If our function is given as an equation, in order to find the y-intercept, we need to plug in x equals 0. So we're trying to find g of 0, which is 3 to the 0 plus 2. 3 to the 0 is just 1, so that will be 1 plus 2, which is 3. So the y-intercept for g of x, we have 0, 3. Then, for the last one, if our function is given to us as a table, all we need to do is look for the row where we have x equaling 0, which is located right here. That tells us that the y-intercept for h of x is 0, negative 1. Now we can run through those four statements using these three values, the 1, the 3, and the negative 1, to see which one of these statements is true. The first one's telling us again that the y-intercept for h of x is greater than the y-intercept for f of x. If that were true, that would mean that the negative 1 for h of x is greater than the positive 1 for f of x, which is not true. The second statement says that the y-intercept for f of x is greater than the y-intercept for g of x, which is suggesting that the 1 from f of x is greater than the 3 for g of x, which is also not true. The third statement says the y-intercept for h of x is greater than the other two, which is essentially saying that the y-intercept for h of x is the largest of the three numbers. And as it turns out, the negative 1 for h of x is actually the smallest of the three numbers, so that one is also not true. The last statement tells us that the y-intercept for g of x, which is 3, is greater than the y-intercept for the other two. And indeed, 3 is greater than 1, and 3 is also greater than negative 1. So statement number 4 is the one that is correct.